Determine whether the complex series summation k equals 0 to infinity of k factorial over 2I to the k converges or diverges. So this is a complex series because we have I in it here. The variable k is the index of the summation that is a real integer. We're going to use the test for divergence, which has two formulations. One of them is that if the limit of ck is not 0 as k goes to infinity, then the summation of ck diverges. So here we're going to show that the limit as k goes to infinity of k factorial over 2I to the k, we're going to show this limit is not 0. Our ck's are the summands here, the terms in our series. So how do we know this limit is not 0? Well, we're going to compute the limit as k goes to infinity of the modulus of this quantity. And if the modulus doesn't go to 0, then the number inside there doesn't go to 0. So we'll use some properties of the modulus. The modulus of a fraction is the modulus of the numerator divided by the modulus of the denominator, and the modulus of a product is the product of the moduli as well. So this limit is equal to the limit k to infinity. The modulus of k factorial is itself, because that's just a positive real number. And then 2I to the k, the modulus of 2I is 2. So the modulus of 2I to the k, using the modulus of a product as the product of the moduli, is simply 2 to the k. So we have k factorial over 2 to the k. This is our limit. And this limit is infinity and not 0. Certainly not 0. To see this, the factorial here is growing faster than the exponential. To see this, we can write k factorial as 1 times 2 times 3 times 4, etc., up to times k. So that's k numbers. And here we have 2 to the k, which is k2s. So under each of these numbers, we can write a 2. So these are lining up vertically. These two cancel. These two are bigger than 1. And all of the others in this line are also bigger than 1. And so that means that this whole fraction is bigger than k over 2 times 2, 4, bigger than k over 4. And the limit as k goes to infinity of k over 4 is, of course, infinity. So this limit is infinity. The factorial grows faster than the exponential. So the limit is not 0. The limit of the moduli is not 0, and that means the limit of the terms themselves is also not 0. And therefore now the test for divergence, the limit of the terms of a series is not 0, so the sum of the terms of the series diverges. The series diverges by the test for divergence.